Hi, this is Mr. Nazarian. Our lesson objective today, I can change improper fractions to mixed numbers and mixed numbers to improper fractions. 5th grade standard, numbers and fractions, A. So what is an improper fraction? An improper fraction is a fraction where the numerator is larger than the denominator. So anytime that you see a fraction like this where the number on top is bigger than the number on bottom, improper. As we look at this, remember just our understanding of what fractions are. The denominator tells us how many parts whole has been divided up into. So there's 4 total parts here in this whole. And the number on top tells us how many are shaded, right? Well, an improper fraction, since there's more numbers that are shaded than total numbers in one whole, that means that there's always more than one whole. It's going to end up being a mixed number, a whole more than one. Well, I shouldn't say always a mixed number. It'll be either a whole number or a mixed number, but it's going to be more than one, because any fraction where you see, let's say, for example, that we're doing just this one, then this as a fraction would be this divided into 4. There'd be 4 total pieces, and all 4 would be shaded, so it would be 4/4, which is one whole. If you had a pizza, you cut it up it was cut into 12 pieces, you ate all 12 pieces, you would eat one whole pizza. So any fraction where the number on top and the number on bottom is the same equals 1. So any time that you see a number where the number on top is bigger than the number on bottom, if it's, in other words, an improper fraction, that means that it's more than 1. So as we look at this 9/4, we have our square divided into 4 pieces. There's our fourths, and we have 9 of them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And so as you look at this, just visually, you can see that there are how many whole squares that are shaded? There's 2, right? Let's do that real quick. So there are 2 whole squares shaded, and then what fractional part of a square is shaded? And in addition to that, 1/4, right? So that tells us that 9/4 is the same thing. It's equal to 2 whole and 1/4. This 2 and 1/4 is a mixed number, and it's a mixed number because it includes a whole number and a fraction. Okay. So I want you to think about something as you look at these, because you won't always be drawing them out like this, right? Just the relationship of these numbers, if you think about 9/4, and remembering that fractions, when we look at fractions like this, we can also think about as this number on top, this symbol also being a division. So it's 9 divided by 4, right? Well, how many times does 4 go into 9? Well, if I'm counting by 4s, right, if I think, well, I've got 4 and 8, right? It can go in 2 times, right? But it can't go in 3 times because that'd be 12. So it goes in 2 whole times, and then there's 1/4 left over. So let me show you another way here so that you can do it to figure it out. So if you think, okay, 9/4 is the same as 4/4 plus, over here, another 4/4, right? That's 4/4, another 4/4 is 8/4, and then you'd need another 1/4 to give you 9/4, right? 4 plus 4 plus 1 is 9, so that'd be 9/4. Well, each of these, like I said earlier, every time that you have a fraction where the number on top and the bottom is the same, equals 1 whole. So we've got 1 whole, another 1 whole, so we've got 2 and 1/4. So that is how you can change a improper fraction to a whole number, or a mixed number, excuse me. And I'd like you to go ahead and give that a go with 8/3. So you have an improper fraction 8/3. Change that to a mixed number, an equal mixed number. Go ahead. All right, so a bunch of different ways you can do it. We could draw this out. I could do, well, I know that it's more than 1, which is 3/3. Could I do another 3/3? Sure, I could. That'd be 6/3. And then I can't do another one. but 6, I need 2 more to give me 8, right? So I've got 3/3 plus 3/3 is 6/3 plus another 2/3 is 8/3. And then remember, the times where I have the top and the bottom are the same are 1 whole. So this is equal to 2 and 2/3. Okay? All right. Well, now here's another thing that we can do. We can change mixed numbers into improper fractions. So we can change them back and forth, no problem. So if I look at this mixed number here, we've got 3 and 2/3, and I have a visual here to show us. Here's 3 whole rectangles shaded in, and then 2/3 of a rectangle shaded in, right? So this shows us 3 and 2/3. But if I want to change this to an improper fraction, so I don't want any whole numbers involved, I just want it to be fraction, which we'll see in the next lesson how that can, examples of when that can be beneficial. So I have 3 and 2/3. I want to change it into an improper fraction. Then I can just count. I can visually make it. I can create a diagram or drawing of it, and then I can count up all of the thirds, right? So I can say, well, it was 1, 2, 3/3 here, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 thirds. 11 thirds. So that would be the improper fraction equivalent to 3 and 2/3. Now, a way that we can do this without this diagram, and again, we can say, well, 1 whole would be 3/3. So there's 1. So even if I didn't have this visual here, I could say of this 3, I've got there's 1 whole, there's 2 whole, there's 3 whole, and then I also have 2/3. Sorry, 2 looks weird. So then I can just add them up, right? 3/3 plus 3/3 is 6/3, plus 3/3 is 9/3, plus 2/3 is 11/3. So that is another way to do it. Yet another way to do it is, and this is kind of a neat fast trick, is I can take this denominator here, 3, multiply it by the whole number, this 3 here, and then add the numerator, the 2 here. So, and the reason for this, the reason why this works, because I say it's a trick, but really it's because of the relationship of these numbers. I'm taking this 3 and multiplying by 3 because of this right here. I've got 3 whole, right, of thirds. So I've got 3/3 once, 3/3 twice, 3/3 3 times. That's why you can multiply the denominator by the whole number. And then I'm just adding how many more thirds I have, the fractional part here. So that's why you add the numerator. So that is why this works. But to show you, you multiply the denominator by the whole number. So 3 times 3 is 9. You add the numerator, 2. 9 plus 2 is 11. So any of those ways works. Why don't you go ahead and give this one a shot? So solve for 2 and 5/6 as a improper fraction. Okay, so I'm going to do it the quick way just for time's sake. You can do it any of those different ways that you want, but I multiply the denominator by the whole number, so 6 times 2 is 12, plus 5 is going to give me 17/6. Again, I could do, well, 2 wholes, we got 6/6 is 1 whole, 6/6 is another 1 whole, and so I just have 2 whole, and then I've got also have another 5/6, and that would give me the same thing, 17/6. Okay, so we are going to work more on this tomorrow. See you then. Bye.